This is a short video to help everyone get used to the F distribution and how to do the homework on section 9.5, which is doing a difference between two deviations or variances. And the way I'm going to do this, I'm going to go into a homework problem for section 9.5 and kind of just show how going through it. So I'm actually in section 9.5, number 8. And this is some sample data of males and females and their weights at the end of their freshman year. And if you click the data, it shows a table here. And what I did is I just said open and stat crunch, click, and then I said open and stat crunch. And I've got that right here. Hold on. All right, so I loaded it and it's got all the, but it's all jumbled together here. So all the male and female are jumbled together. So I had to go to data and I had to hit sort, and I sorted by both sex and weight. So you hold shift and it'll shift them by both. It'll organize them. So I did that, and then here's the column that it comes out. And the bad thing is it put all the female first and then all the male second, so it still need to be able to find the mean and standard deviation of these groups. So what I did was I actually clicked and highlighted like all the males, and I hit copy and then I hit paste. So I copied them and pasted them in a new column, and then did the same thing with the females. So that's what I've got here. var 5 and var 6 are just the male and female weights because I need to find the mean and standard deviation of these. Really, I just need to find the standard deviation. And then once I do that, I can just go stat, summary stats, columns, and I can just do var 5, just var 6, and hit compute. And there it is. There's the two standard deviations. So there's the men, standard deviation was 9.72, and the women was 6.23. So if I go to our notes, and I'll actually show you where I've uploaded the write-up of this on Blackboard. So if I go to class notes, inference with deviations, and I'll go to the write-up of this. But I want to show you on StatCrunch how to get the data loaded, and then what you have to do there. And I'm going to go all the way down here to the end. Let's see here. There we go. So there it is. So our null hypothesis would be that they're equal, that the standard deviation, and it says we're comparing the standard deviation of the two, male and female. The null hypothesis is that they're equal. The alternative is that men is higher. We think men would have a higher variation because their weights are significantly more, so those numbers would seem to warrant a higher variation too, just because like I was saying in my class, like 10 pounds to me versus 10 pounds to my wife are very different things. They're much different percentage comparatively. So like a 10-pound variation in male is different than a 10-pound variation in female. So we would expect the male variation to be higher, but that's what we're testing to see if it's significantly higher. So the F test is found by taking the standard deviation squared and dividing those. So if I take, and I'll go back to my little printout here. So if I took 9.72 and squared it and divide it by 6.237. If I took the two deviations squared, which is the variance, if I just take the variances, squaring the standard deviation gives you the variance. If I take those and find that ratio, that is the F statistic. So if I took 94.64516 divided by 38.90, I would get right here, I would get this 2.43. So you're like, okay, great. Is that good or bad? Well, let's imagine if they were identical, if the variances were identical, the F statistic would be 1 because it'd be the same number. And we always put the larger one in the numerator. So it's the larger divided by the smaller. Now, we do have some F tables on your in the formula sheet, but honestly, in your formula sheet area, but we're not really going to use those. We're going to go jump right to StatCrunch. So if I go to StatCrunch and I go to calculators, so stat calculators F, and I just say degrees of freedom, this would be the degrees of freedom of the numerator. So the question is how many men were there? Let's see if it's got that. the raw data here, sorry. Well, let me close that. So if we look at the men and the women, so for the men there was 32, and for the women there was 35. So if I take n minus 1, degrees of freedom minus 1, so that's going to be 31, and for the women there was 35, so I'm going to put 34. So that's the degrees of freedom of each, and my t-stat was 2.43, I believe, and I want to find greater than. We always want to find the 8 to the right when we compute. So there it is. It's way out here in the tail. It's 0.006. So the probability we would get this much difference by random chance is less than 1%, 0.006. So if I go back to the homework here, the p-value is 0.006. Now, if this was a two-tailed test, that means if we're saying, instead of just saying it being equal, it made it not equal. Like here's another write-up. This is one-tailed. The variances are equal. The alternative is that they're greater than. Number 2, I think, in your homework was two-tailed. Yeah, so like this one right here. Number 2, the null is that they're equal. The alternative is that they're not equal. So that's a two-tailed. So once you calculate your F statistic, calculate your p-value, which is 0.315, you have to double it for two-tailed. But on this example, number 8, it's one-tailed, so it says 0.006. If it's two-tailed, we'd double it. Now, on your test, I'm not going to ask you to really calculate any of this. I'm just going to tell you, here's the situation, and then you kind of tell me what you think. Well, in general, for the p-value is less than alpha, or significance level, we're going to reject the null hypothesis. And so that means there is sufficient evidence to support the claim that near the end of the freshman year, weights of male vary more than female. So those weights have a higher deviation, and very significantly higher deviation. So that's pretty much it. And there's only 8 problems on the homework. And like I said, there's only going to be 1 on the test about this. And I will be giving you the F statistic and the p-value. You just have to kind of infer, what would be the null and alternative maybe, and would you reject or not reject based on the p-value given. So hope that helps with these. And like I said, the write-up is in the notes there on Blackboard for several of the problems, so I'd encourage you to take a look at those. And that's about it.